right, we are going to now review our trig unit. And again, I'm not going to do every problem. I'll give a review couple. In each section, you get a feel for what you should be doing. So the first section, each degree measure in radians and each radian measure in degrees. So these ones, this whole in the calculator section, you are allowed to use a calculator here. If you want to convert, because radians have the pi in it, so we multiply by pi over 180. Now, the negative 37 doesn't have a denominator, which means its denominator is 1. So when we multiply straight across, we get negative 37 pi over 180. Now, our next step would be to reduce this. However, 37 is prime, and we cannot reduce that. There's nothing else that we can do. So if these had common factors, we would reduce it, but in this case, they don't, and so that is our final answer. When we're doing the opposite of that, when we're taking a radian measure and converting to degrees, instead of multiplying by pi over 180, we multiply by 180 over pi, because when we do that, the pi's are going to be across from each other and we can cross cancel them. So the pi's will go away. I also prefer to reduce at the beginning rather than at the end. If you prefer the other way, that's certainly fine. You can multiply 3 times 180 first and then 2 times 1 and then reduce. I prefer to see that 2 and 180 are both divisible by 2. 2 divided by 2 is 1. 180 divided by 2 is 90. And so then my 3 times my 90 is 270 degrees. Find the reference angle for each angle given. Remember that the reference angle is how many degrees is the angle away from the x-axis. So you probably need to know where the angle is and be able to kind of sketch it or use your unit circle to find it as well. So negative 150. If I'm graphing negative 150, I go here 150 degrees. Looks like this. The reference angle is this. How far away is it from the x-axis? Well, the x-axis would be negative 180. So this is 30 degrees away from the x-axis, so that is my reference angle. Let's look at this one, 7 pi over 4. So first of all, if I look at that, I see that that is 1 and 3/4 pi. So if I'm sketching that to look at it, 1 pi is here. Then I need to go 3/4 of a whole nother pi, so that would be over here. So there's the sketch of the angle, the reference angle, how far it is from the x-axis. Your answer has to be in the same form as the original. It needs to be in radians. That's 1/4 pi away from the x-axis. Notice that the denominators match. This is a denominator of 4, this is a denominator of 4. All right, 7 and 8, solve the equation for theta, round to the nearest tenth. So this is the one where we've got a couple different steps. And doesn't necessarily matter which one we do. Let's do number 8. Let's look at the tangent. So the first thing you need to do, because we have been told that the tangent of theta is negative 0.88. So the first thing you should do is in your calculator, you should do the inverse tangent of negative 0.88, because that is going to give you an angle that has that tangent. So that part's in the calculator. Make sure that it's in degree mode. That's going to give you negative 41.3. Now, everything we base these answers off of is going to be based upon our reference angles. So negative 41.3 is right here. It is 41.3 degrees away from the x-axis. So that's my reference angle, is 41.3. Once I have the reference angle, now I need to go to the second piece of information that they gave me. I want my answer between 90 and 180. which means I need to go to that quadrant, which in this case, that quadrant happens to be quadrant 2 between 90 and 180 is right in here. And I need to go 41.3 degrees into that quadrant from the x-axis. So the x-axis here is at 180. I need to go 41.3 degrees from that 180. So I take the 180, and in this case, I'm going backward. I'm going less than 180. So I take 180 and I subtract my reference angle. Remember, you're not always subtracting from 180. It depends on what quadrant you're in. So 180, in this case, minus 41.3, gives me a theta of about 138.7 degrees. So do the inverse trig function first, then find the reference angle, then use the x-axis to find the final answer. Those are our steps. All right, 9, 10, and 11, we are solving the triangle, which means we are finding all the missing sides and angles, which I've conveniently labeled for you here. Now, some people were confused at this part. This is to help you organize, to help you realize what you should be doing to solve the problem. So first thing you need to do is you need to draw yourself the triangle that is described. So it says A is 60 degrees. So I'm going to draw an angle A here that looks to be about 60 degrees. Then side B. Well, side B could be either of these. It doesn't matter which. It says it's 10. So we'll make this 10. Then it says side C is 8. Well, C is going to be the other one next to it because side A has to be across from angle A. So this is side A. So if I made this 10, that means this is angle B. So this is angle C, and side C was 8. So here's my picture. You need the picture to figure out what the letter combination is. This one is side, angle, side, because it has two sides and an angle, and the angle happens to be between the two given sides. So what this tells us is that I have to use law of cosines, because law of cosines is used whenever it's side, 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 or side, angle, side. The two triangles question mark just means, could there be two triangles? No. The only time it's going to be a yes is if this is side, side angle. So this one is not, so there is no possibility for two triangles. You don't even have to look for them. So I know I'm using law of cosines, so in order to set it up, I need to use the angle that I have, which is angle A. So that means side A is going to be the one on the side by itself. So when I set up the law of cosines, it's going to be A squared equals, and then it'll be B squared plus C squared minus 2BC times the cosine of A. Remember that when you set this up, these two should match. The angle and the side that's on by itself should match. These two should match these two. Okay, so then now it's just a plug and chug. So A squared equals B squared, which is 10 squared, plus 8 squared, minus 2 times 10 times 8 times the cosine of 60 degrees. So when I simplify, this is 100, this is 64, so that's 164 minus 2 times 10 times 8 times the cosine of 60, if you punch that into your calculator, will give you 80. So that means A squared is 84. Take the square root on both sides, and that'll give you side A, which is 9.2. So now I need to find angle B and angle C. Once you have done the law of cosines once, you can switch over to law of sines. So if I want to find angle B, I can do sine of A, which sine of 60 over A, which is 9.2, equals sine of B over B, which is 10. And then cross multiply to solve. I'm not going to finish this one. I think you should be able to finish the B and the C here. So I've already set up B for you. Once you know what B is, C, you just use the fact that the triangle sum has to be 180 degrees to finish. So let's look at 10 real quick. It says angle A is 70 degrees, so a little bigger than the last one. So 70 degrees for A. So side A is 25, so that's the one across from angle A, so this is 25. And then side B is side C is 26. Well, this one looks pretty similar in length, so that's side C, which means this one right here is angle C. This is angle B, and this then has to be side B. So now I look at the setup. I've got two sides and an angle, but the angle is not between. So this is side-side angle, which means this is law of sines, and it is the ambiguous case, which means, yes, there could be two triangles. There aren't always, but it means we do have to check for the second triangle. All right, so first thing I'm going to do, I know it's law of sines. I'm going to set up that proportion here. So sine of 70 over 25 equals, I only know side C. So if I have to use side C, that means I have to find angle C first. So sine of 70 over 25 equals the sine of C over 26. So cross multiply. And so then 26 times the sine of 70 is what I get over here. Then I get 25 sine of C on the other side. So I'll divide it by 25 in order to find the sine of C. Oh, my pen went a little crazy there. So if I divide all this out on my calculator, it should give me about 0.977. So that's what the sine of C is. Please don't record that measure for angle C. That's what the sine of C is. So then to find C, C is going to equal the inverse sine of 0.977. So when I do that, I get 77.8 degrees. Now, I know that I have to check for an ambiguous case, so I'm going to write or here. But I'm going to come back to that later because I'm going to finish solving the first set first before I look at the second set. So if I know that angle C is 77.8, I can find angle B by taking 180 minus the 70 that I was given and the 77.8 that I just figured out. And that is going to give me angle B. So when I do that, I get 32.2 degrees. Again, I know that there's going to be an or, but I'm going to leave that until I finish this one. So now I need side B. So that means I need a law of sines. So sine of 70 over 25 equals sine of 32.2 over B. So again, I'm cross multiplying here. So 25 sine of 32.2 equals sine of 70 times B. So that means I'm dividing this by the sine of 70. So in your calculator, do 25 sine of 32.2, divide it by the sine of 70. That'll help you find side B, which hopefully you get at 14.2. So that is my one solution. Now I need to find my ors. When I start out with my ors, I start with the original thing that I solved for, which was angle C. So angle C, I take whatever I originally got, and to do the ors, I do 180 minus that answer. So 180 minus 77.8 is going to give me 102.2. So 102.2. So once I have that, then I just continue solving. I don't use this information again. I'm only using what I was given, which are these three, and my 102.2. So to find my other angle B, if one angle is 102.2 and another angle is 70, that means that angle B has to be 180, subtract that sum. So I add the 102.2 to the 70, I subtract that from 180, so the or for angle B is very small, but it works, 7.8 degrees. Now if it didn't work, like let's say that the 70 plus whatever you got was bigger than 180, then that would mean that there aren't actually two triangles and you don't have to solve the second case. So now I've got angle B, angle C. I need to find my alternate side B. So I set up the exact same thing that I did for the first side B, except on the right side, instead of sine of 32.2, I put in the angle B that I actually got, which is sine of 7.8 over B, and I do the exact same thing. So I do 25 sine of 7.8, and I divide that by the sine of 70. You should get 3.6 for the alternate angle, or side B, I mean. All right, 11 is a right triangle, 90-degree angle, so that means you can use your SOHCAHTOA to solve this one. So angle B, if angle A is 20, 90 minus 20 gives you angle B, so it's 70. Then side B. Side B would be right here. That is the adjacent side. The side that I know is the opposite side. This side C is the hypotenuse. So when I'm setting up my trig function for side B, I'm using adjacent and opposite, so that's tangent. So tangent of 20 equals opposite over the adjacent. So if I want to solve for B, B is going to equal 0.7 divided by the tangent of 20. So do that, you should get 1.9. Then C. C is the hypotenuse. So if I'm using hypotenuse and opposite, that is sine. So sine of 20 equals the opposite over the hypotenuse. So again, you switch these two places, so C equals 0.7 divided by the sine of 20. So that should give you about 2.0. All right, 12, surveyor wants to find the width. So the main thing here is knowing the variable. This is what you're looking for. That's the width. Then you can see this is angle side angle. So you should be setting up a law of sines to solve this. I'm not going to set it up. I have set up tons of laws of sines here in these previous problems. So now that you know what you're supposed to do and that this is your x, find the missing angle because you know the other two and set up your law of sines to solve. All right, the back. If you didn't read the directions, review for the no calculator, non-calculator part. You will have a unit circle for this part of the test, just like on the quiz, but you cannot use your calculator, so don't use your calculator to do the review. All right, so we've reviewed these a whole bunch of times, so we're just going to look at a couple of them. I'm going to do 15, so sine of negative pi over 4. So if I look at the unit circle, if I can get it to come up here. Come on, unit circle. It does not want to come up for me. All right, so while we're waiting to see if it's going to decide to actually show up, oh, there it is. Lovely. So there's my unit circle. And it disappeared again. Sorry, technical difficulties. Okay, here's my unit circle. It wanted negative pi over 4. So negative pi over 4, remember, is not the same as positive pi over 4 because you're traveling in the clockwise direction, but it has the same reference angle. So this is the middle angle. It's the 45 degrees. So when I go negative, it's the same thing. It's the middle angle. So negative pi over 4 is right here with the 7 pi over 4. Those are coterminal. So if I look at those values here, it's radical 2 over 2 and negative radical 2 over 2. So I'm going to write that down. It's not my answer, but I'm writing it down. Radical 2 over 2, negative radical 2 over 2. Because I need to know which part is my answer. I'm looking for the sine of that. Sine is the y value. So this is going to be your answer for sine of negative pi over 4. Then let's do 18 as well. Tangent of 5 pi over 3. So 5 pi over 3, that is 1 2/3 pi. So that should help you figure out where to look for it. So if it's bigger than 1, it's in quadrant 3 or 4. And 5 pi over 3, I found it right here. So here are the coordinates that I'm going to need. You're always going to need this ordered pair to solve for any of them. So it's 1/2 negative radical 3 over 2. So 1/2 negative radical 3 over 2. Now, unlike on 15, where sine was just the y, tangent, remember, is the sine divided by the cosine. So the sine, negative radical 3 over 2, divided by the cosine, so divided by 1/2, means that I'm going to take negative radical 3 over 2, multiply by the reciprocal, the 2's cancel. Oops, and I forgot to bring over the negative. That would make a difference. And so I've got negative radical 3 on top, 1 on the bottom. So the answer is just negative radical 3. And there we go. 19 through 24, evaluate. Give your answer in degrees and radians. If those directions don't give you a clue as what to do, you've got a problem. It's looking for an angle because it says in degrees and radians. So it is asking what angle has a cosine of negative 1/2. So you look at the unit circle. Cosine is the x value, so I'm looking for negative 1/2. I know that I'm going to be looking only in 2 of the quadrants because all scholars take calculus tells me that cosine is positive in quadrant 1 and in quadrant 4. So I'm looking only in quadrants 2 and 3, and I'm looking for negative 1/2 as the x value. I found it here at 120. I also found it here at 240. So you're going to list these two because that's the degrees, this is the radians, and you're going to list these two. So we found it at positive 120 and at positive 240. This one was 2 pi over 3. This one was 4 pi over 3. All right, let's do one more of these. 22, it says the cosecant is 2 radical 3 over 3. Well, cosecant is the reciprocal of the sine. So I'm going to reciprocal this. That needs rationalized. So that gives me 3 radical 3 over 2 times 3, which is 6. These reduce, gives me radical 3 over 2. So if the cosecant is 2 radical 3 over 3, that means that the sine was radical 3 over 2. So I'm looking for when the sine of theta is radical 3 over 2. So now I've converted it to something that I can actually look for on the unit circle. So I go to my unit circle. I'm looking for a y value of radical 3 over 2. I see it here, and I see it here. Down here, they're negative, which is not what we want. So we see it then at 60 degrees, pi over 3, and at 120 degrees, which is 2 pi over 3. So my answers for 22 would be 60 degrees, 120 degrees, pi over 3, and 2 pi over 3. All right, some graphing here. Let's see. I'm not going to do all of these. You can go back to the very short videos of graphing if you have a problem with it. I'm going to do 26 because it's got the most going on here. And then I'll start 27, but I'm not going to finish it. So 26, it's a cosine graph, so I know that my domain is going to be all reals. I know that my range is going to be a sandwich. I don't know what yet. Amplitude is the number in front. The amplitude's 1 because nothing's in front of there except a negative. I had suggested that you write yourself a little note. that this is going to be a reflection. When you know that it's negative, you have to remember to reflect, and I know that I forget a lot. So write yourself a note here so that when you're looking at it, you're going to remember to do it. The period in a cosine graph is 2 pi divided by b. So in this case, my b value is 4/3. So 2 pi divided by 4/3, which is the same as 2 pi times 3/4. So top times top gives me 6 pi. Bottom times bottom, this denominator was 1, is 4. So that reduces, and I should get a period of 3 pi over 2. So I check to make sure I've got the right number of marks here, which I do. I need 4 for the sine and cosine graph. So my period's going to be 3 pi over 2. The halfway mark I need to label, and it's just half of whatever this is. Divide it by 2, which is the same as multiplying by 1/2. So this one should be 3 pi over 4. So label the left side 2, negative 3 pi over 4, negative 3 pi over 2. My vertical shift, if I look at my equation, is 2. So that means very first thing I do on my graph, other than my label, is I draw my new midline. So this had a vertical shift of 2. So I shift my midline up 2. Counting by ones here. If this is my new midline and my amplitude is 1, cosine graphs start at the max typically. This is a reflection. So instead of starting at the max, it starts at the min. And the min is whatever the amplitude is away from the midline. So 1 is the amplitude, so I go 1 unit down from the midline. That's my minimum. And now I'm just going to use my pattern. So this is my starting point. After the min, I go back to the midline at the next one. Then I need to go up to the maximum. Then back to the midline. Then back to the minimum. That gives me a full cycle. Then on the other side, this one was the minimum, so I go back to the midline. Then I need to go up to the max, back down to the midline, and then to the minimum. So then connect them. And there is my graph. Last thing I need to do is fill in my range. So I look at the range. The lowest number is 1. The highest number is 3. And I'm done. All right, tangent I'm just going to set up and not necessarily graph the whole thing. You know that you're going to have asymptotes at the halfway mark, so put those in. The main thing I'm concerned about here, you've got a vertical shift of -1, so that means instead of starting at the axis, we're going to be starting down 1 from that. So that is where my starting point would be. My period on tangent, it's pi divided by b, so it's pi over 2. So pi over 2 here, pi over 4 here, and hopefully you should be able to finish the rest of the graph from there. All right, last one. Looking, excuse me, looking at the graph and trying to figure out my equation. So I'm going to look at 29. And first thing I'm going to do, I'm looking and I see that my vertical shift is none. It's 0. And you can write none if you want, because the middle of the between the min and the maximum is the axis. So there was no vertical shift here. The amplitude, how far from the midline is the maximum? Well, if this is 1, this is halfway to 1. So that means the amplitude is 1/2. So then finally my period. I know my period goes from max to max. If I'm counting by eighths, this is pi over 8. This is 2 pi over 8. This is 3 pi over 8. This is 4 pi over 8, which does reduce to pi over 2. So that's how I know my period is pi over 2. I can use that to get my equation. So I know my A value, and I also know that since this starts at a max, that this is a cosine graph. So I can do 1/2 cosine. But then, to find my B, remember on a cosine graph, it's 2 pi over B equals the period. So the period is pi over 2. I got that because of this length. That's the period. So now I just need to solve this. So cross multiply. B pi equals 4 pi, which means pi's cancel. B is 4. So cosine 4x. So that is my final equation. And that should wrap up your review. Please, please, please study.